Okay, now we know about tens complement and how it has built-in subtraction, and we can use that to do subtraction by addition. Okay, we can do the same thing with a different base, only this time it would be called two's complement. Okay, so to get two's complement, what you do is you take a number. All right, so let's say we're going to represent minus 25. You take the absolute value of that number, all right, then you write that out in binary. So you'd have to convert 25 to binary. We've talked about this division by 2 method. Okay, so that would convert to 0, 1, 1, 0, 0, 1. Okay, and you can check that. Okay, from there, you flip all the bits. So this 0 becomes a 1, this 1 becomes a 0. Okay, flip all the bits, and you get this binary or this hex pattern. So these 4 digits would be a 6, and this would be the 2. All right. From there, you add 1. So 26 hex plus 1 is 27. There's the answer. All right, so there's another way to do this because mathematically, it's just like we did with tens complement. Instead of 10 to the n minus x, we're doing 2 to the n minus x. Okay, so the number of bits is important. In this case, we have 6 bits. 2 to the 6th is 64. 64 minus 25 is 39. Okay, from that, you convert 39 to binary. Okay, and when you read this in binary, this would be 0, 1, 1, 1, which is a 7, and then the 2 here. Okay, and you can double check that. 2 times 16 is 32 plus 7 is 39. Okay, so 2 ways to do the problem, you get the same answer. Okay, let's go one more. Let's do a 7-bit case, and let's go with minus 34. Okay, so what do? Let's do the flip and add 1 method. So minus 34, you convert that to positive, take the absolute value, convert 34 to binary. Okay, again, that takes a little work. You can use a calculator, but you can also do the divide by 2 method. But then checking our answer here, we have the 32nd place, 32 plus 2 is 34, and the hex pattern would be 0, 0, 1, 0, which is 2 and 2. All right, so work through these. Look at these. Make sure you can check these answers. Then the next step we do is flip all the bits. All right, so this 0 becomes a 1, this 1 becomes a 0, and so forth and so on. You look at the hex pattern there. This would be 1, 1, 0, 1 for D, and 1, 0, 1 for 5. Okay, so from there we add 1. 5D plus 1 is 5E, and that's our representation. That's the bit pattern that represents minus 34 with 7 bits. Okay, another way to get there. Another way to get there is to take 2 to the 7th, 128. 128 minus 34 is 94. Then convert 94 to binary. All right, going through that process of conversion. And you get back the hex pattern 5E. Okay, so you see these match either way. 2 ways to take the 2's complement to represent a negative number.